talk about the horizontal component, and I'm going to find x of 4.645. Okay, this is going to be 82 times this number. Cosine is 65 degrees. When you do this in your calculator, if all you do is type in 82 and then round that number right there, you are losing accuracy. So what we want to do is either hit second answer, or we want to hit X because it's stored for X, or if you want to store it in for another letter, be my guess. All right, and we get 160.965. 160.965 feet. And that's the most accurate answer. Okay, now let's look at the next problem. Here we have an archer shooting an arrow with an initial velocity of 60 meters per second. Notice that we're in meters now. Okay, and we've got an angle now at 4.8 degrees with the horizontal at a target 70 meters away. So this is going to give us something about our horizontal distance at the end. If the bow is held 1.4 meters off the ground, so this is going to be an initial height, how far off the ground will the arrow be when it hits the target? Well, okay, let's just go ahead and write our two equations. X of t is going to be 60t cosine of 4.8 degrees. I'm just using the formulas from the front. And my vertical component is going to be 60t sine 4.8 degrees. All right, minus half of 9.8, which is going to be 4.9 t squared. If this was in feet, I would do minus 16t squared. And then I need to go ahead and add in my 1.4, all right, which is my initial height. Okay, so then they're saying, how far off the ground will the arrow be when it hits the target? All right, let's think about this. Let's think what makes sense. So when the arrow hits its target, okay, let's think. When the arrow hits its target, that's talking about a time when the horizontal distance is 70 meters away. So I need to figure out what that time is first. Okay, so what I'm going to do is say, okay, well, when the arrow hits its target, the horizontal component will be equal to 70, and let's figure out what this time should be. Okay, so in essence, I'm just solving the equation for t here. So this is going to be 70 divided by 60 cosine 4.8. Now this is not answering the question, it's just giving me that time. Then I can figure out what the vertical distance is. How far off the ground will that be when that happens? Okay, so let's, in our calculator, do 70 divided by, I need to use parentheses here, cosine 4.8. All right, and I have 1.171. And keep in mind, this is also a rounded number, so if I use it, I don't want to just plug in 1.71. I want to get exact. Okay? So when I get to the next part, when I get to this next part, I want to find y of 1.171. Okay, I can write it out if I want to, but I'm not going to use 1.71. I'm going to use either the stored value or the second answer feature. I didn't mean to do parentheses there. Sorry, here we go. 1.171. Okay, so let's think about this. This is going to be 60, and then I'm going to hit second answer, sine of 4.8, okay, minus 4.9, parenthesis, second answer again, squared, and then plus 1.4. Okay, and I get 0.562. They're going to be meters. So my accurate, I don't have rounding error, I have an accurate answer. Okay, so when the arrow hits its target, or when the arrow has gone 70 meters horizontally, which happens to be 1.171 seconds, then the arrow is also 0.562 meters off the ground, which should make sense that it's not going to be that much off of 1.4. Okay, now the next part, what is the maximum height the arrow reaches? This is something we actually could have done a long time ago. Now I have a more complicated vertical, I have something that also depends on the angle, all right, but this maximum height, we can do this in our calculator. Okay, so let's plug in our vertical component, 60x sine of 4.8 minus 4.9 x squared plus 1.4. And again, I'm going to go to my window and I'm going to think what makes sense. Now, I already know that this arrow is, it takes less than 2 seconds to even get to the target. So I'm going to change that to 2. And my Y max doesn't need to be 50. It only needs to be maybe like 5 at most. You know, maybe a little bit more. We'll say 10. We'll say it does go higher than a person. We'll be on the safe side and hit graph. So here you can see our arrow. It does have a little bit of an arch to it. Now, I'm not graphing the actual path of the arrow. This is not my parametric. This is just the vertical component. So this is not representative of the horizontal component at all. It's the vertical component in time. So I just wanted to point that out, although it didn't really matter in this problem whether you understood that or not. So I want to find that maximum height. So I'm going to use the maximum feature. Now something interesting is next year in calculus you will be able to find these maximum and mins based off of a simple algebraic move, but we're not ready to do that yet. But our calculator finds it for us. Make sure you do go all the way to the left and all the way to the right. Don't get lazy here and try to shortcut your way through this, because you might be cutting off the true max. Okay, so I have two numbers here, so I got to think about what they mean. X here is not actually X, meaning horizontal. It's the T, it's the time. And the Y value here is 2.686, and that's the number that I really want, because they're asking for the maximum time. So there wasn't a lot to do for the second part. We did most of it on our calculator. I'm going to draw a little picture here just to show you. That's that right there. Okay, last problem. So on the 7th hole of the U.S. Open, Tiger Woods, at the time we wrote this question, there was no scandal involving Tiger Woods, so this is, he was actually an upstanding role model at the time. Estimates the distance of the pin to be 220 yards. His swing provides an initial velocity of 160 feet per second, so V is going to be 160. And I am going to go ahead and change this 220 yards to be 660 feet before that trips me up. It says we've got an angle of 28 degrees. And it says determine whether or not Tiger makes a hole-in-one. Assume he is directing the ball straight at the pin, because if he was off, if you're thinking of his line of sight to the ball, if he's off right or left, then obviously that would be a mistake. But we're just thinking simplest case here. So let's go ahead and write our two equations. X of t is going to be 160t. Should be getting really good at this. Cosine of, in this case, 28 degrees. And y of t is going to be equal to 160t sine of 28 degrees. Now this is in feet, so we're going to do minus 16t squared. And it doesn't say anything about an initial height, which makes sense because a golf ball would be on the ground. And the height that the tee offers is minimal. Okay, so what we're thinking about here is what is the time that it takes the ball to get there, and then will he have enough initial velocity to make it horizontally? Okay, so first what I'm wanting to find out is what is the time to the pin? So, or what is the time, I guess I should say not what is the time to the pin, but what is the time that the ball's in the air? Okay, so let's go ahead, because I'm going to tell you the answer to this. There are other ways you could figure this out, but due to the nature of the answer, which I already know, this is the most direct way to answer this problem. Because if he overshoots on his first strike, then it's not a hole-in-one. So let's think about this. Okay, we are going to use the vertical component. We are going to plug in that equation, 160x sine of 28, then minus 16x squared. And again, go to your window. Think about how long this ball could be in the air. It's going to be longer than the arrow, but I'm thinking not longer than 10 seconds. Probably much less than that. The highest the ball is going to go is probably much higher than 10. Let's go ahead and put 100 in. Okay, so this is not showing all three variables. This is just showing the height of the ball and time. And if I want to find how long that ball is in the air, this is like what we did on problem number 1. We need to put in a 0 here. And I can estimate what it is. It's, it looks like it's between 4 and 5 seconds. But if I want to find it exactly, there we go. And so that's the time that the ball is in the air. All right, now if he has more than 660 feet of horizontal distance in this amount of time, then he is overshot. If he has less, then we would have to do more calculations to figure out if he had enough velocity to then get him to the pin, which is actually more than we want. So we're hoping this is an easy no here, because the yes would be very hard to assume. Okay, so this right now, we have this stored in for x. All right, let's go ahead and write down what that number was, or the approximation of this number. All right, now again, what we're doing here, we use that to find the time that the ball was in the air. But what I'm really concerned about is this horizontal distance. Does he make 660? Is it too far? If it's way too less, all of those things. Okay, so let's think about then what is x of 4.695. So it's going to be 160 times 4.695 times cosine of 28 degrees. And when you do this, don't use 4.695, use the actual number. So remember, just to kind of prove it to you again, here we go. That number is stored in for x, temporarily anyway. So I'm going to use that number, cosine of 28. And this is over 660. If you had rounded here, it could mean the difference between not knowing the answer. So when the ball hits the ground, which is 4.695 seconds, all right, that is more horizontally than where the pin was. So he overshot it. So he did not get a hole-in-one. Okay, so let's mark this down on our... So, no, he overshot. Again, if this number had been less than 660, you'd actually have to do a little bit more work to say that the answer is yes, but this is an easy no. Okay, bring your questions to class.